Hey everyone. So today we're going to be looking at the scientific method. You're probably familiar with this. You probably talked a little bit about this in your last science class, probably a little bit over seventh or eighth grade, especially if you did a science fair. The scientific method is a big part of that whole process. And really today what we're going to be looking at is what is the scientific method, and how do scientists use this to solve problems? So when I was perusing around and just kind of looking up what science is, I found that the dictionary definition of this is science is the study of phenomena, the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. And when we're thinking about science and we're kind of approaching it, we're trying to explain something in the natural world, something that is out there. Why does matter behave the way it does for us specifically in our chemistry class? I really love this little graphic here. It shows us that we're going to be starting with an observation, moving into asking a question, creating a hypothesis, testing that hypothesis with the use of a controlled experiment, analyzing and concluding. And notice it's cyclical, right? You do this over and over and over again. You have to repeat. So the scientific method is a few steps. First, once again, you're going to make an observation. This observation is going to be qualitative or quantitative. After you do that, you're going to be trying to explain why the thing that occurred in nature occurred. You usually are going to be stating a hypothesis. And a hypothesis is a guess you can test. It is some sort of explanation for the observed phenomenon. Once you go ahead and propose your hypothesis, you test your hypothesis by designing and executing an experiment. You make some sort of conclusion, whether it's for or supporting your hypothesis or against or refuting your hypothesis, and then you repeat. You always want to kind of further understand the piece of matter, the substance that you're studying in the natural world. Science is never a one and done process, as much as a lot of people will lead you to believe. So let's get into this. What are observations? You're probably fairly comfortable with making observations. You do this literally every single day. You're using your five senses to examine nature, and specifically gather information. For chemistry, it could be how something looks, how something smells. We try to avoid taste, but sometimes there is food chemistry, and you want to know how things taste. Usually, we're very safe, and we know that the things we're putting into our bodies won't harm us. And hopefully, we're comfortable with the fact that there are two types of observations: quantitative and qualitative. A quantitative observation is really just a measurement. It is going to be something that involves numbers and units. For example, I could take a sample of carbon at school, put it on a scale, and say this sample of carbon weighs 5.1 grams. The 5.1 grams is a quantitative observation. The qualitative observation is basically any sort of observation that does not involve numbers. It can be color, smell, texture, size, even. If you're not using numbers, something is large or small. So if I'm going back to that sample of carbon that I have at school, that sample of carbon is usually like very dark gray or sometimes even black in color. So qualitative and quantitative observations are observations that do not and do involve numbers, respectively. So moving on, after you make that observation, you're going to propose a hypothesis. And once again, that hypothesis is a guess you can test. I've always liked this. I got this from a kindergartner that I was teaching one time. And he just like raised his hand in class. He's like, a hypothesis is a guess you can test. And it was just like, excellent. That's exactly what we're going for. That's exactly what we're kind of thinking, because this guess is essentially an explanation for that observed phenomenon. And the most important part is that the hypothesis, your guess, is testable. You can go ahead and create an experiment to see whether or not the guess you made was appropriate or inappropriate. Last but not least, a hypothesis can never be proven true. It's only ever supported or refuted. The idea behind this is that we don't always know every single aspect of the natural world. So saying that something is behaving because of this reason without any reasonable doubt is just bad science. You want to be a skeptical science. And we can assume something to be true, but we always leave a margin of error, like a very small 1 or 0.5%. And that is good skeptical science practices. So moving on, after you create that hypothesis, you want to test that hypothesis. The tested hypothesis, or excuse me, that test is called a controlled experiment. And a controlled experiment is going to be where you change one factor at a time. We call these factors variables. And it's very important that we only change one variable of the experiment at a time, because if you start changing more than one thing and there ultimately is a change in the experiment, you don't know which one of those variables or factors changed that resulting change in the experiment. It is important that in a controlled experiment, you only change one factor or variable at a time. And there are three types of variables. You'll see what I mean in a second. The first is the independent variable, or the manipulated variable. And these are going to be the factors or the variables of the experiment that are changed by us, the scientist. We're saying, okay, if I change this piece of information about the natural world, how will that result in some other change in the natural world? For example, if I stopped watering a plant, so the amount of water I'm giving a plant is the independent variable. If I stopped watering it altogether, then somewhere down the line, something may happen. Next, we have the dependent variable. The dependent variable is going to be the factor of the experiment that is changed based on the independent variable. So going back to my example, if I stopped watering a plant, what's probably going to happen? The plant's going to die. It is not getting an essential resource that it needs. So the dependent variable in this case is the plant dying. Last but not least, because there are so many other aspects of experimentation, anything that is remaining constant in the experimentation is called the control or constant variable. They remain unchanged, and that means that we know that these aspects of our experimentation are not ultimately changing the dependent variable. So in terms of my plant experiment, this could be the type of soil, the time of day, where in my house I'm even keeping the plants that I'm watering versus not watering. Oftentimes we have to analyze data, and we do so via graphs. Graphs are a very important part of this, and one of the important things that I want to kind of show you all about this is that when we're looking at graphs, when we're kind of analyzing, we're always going to be putting the independent variable on the x-axis, independent variable on the x-axis, and the dependent variable on the y, dependent. This is a nice way of representing graphs, and something that you should be slowly familiarizing yourself as we learn more about science in these next few weeks. So in this case here, the day of the week is the independent variable, while temperature is the dependent. So depending on the day we're taking the reading, the temperature outside is going to be different. So moving on. Last thing that we're going to kind of talk about, last two things, we're going to be talking about theories and laws. So let's go ahead and first start with theories. Generally speaking, if I test a hypothesis over and over and over and over again, and it continually supports my hypothesis, like the experimentation, the results of the experimentation continue to support my hypothesis, then that hypothesis can slowly morph into a theory. Theory, once again, as stated right here, is a well-tested and supported hypothesis. Theories are often ideas and used to account for situation, and they're generally assumed to be true. They're assumed to be true because no matter how many times we slowly manipulate and change our experimentation, our hypothesis, our original hypothesis, was held up. But with that being said, I want you to think about this. I'll ask you guys in the next class. Can a theory be proven true? Is it with 100% no doubt truth? So I want you to think about And last but not least, theories are not the same as laws. These are technically two different things in the world of science. A law is a description of an observed phenomenon. Oftentimes with laws, we have some sort of mathematical formula associated with that thing. Once again, it is describing the observed phenomenon, whereas a theory is trying to explain why that thing is occurring, kind of reasoning for why that phenomenon is occurring. And an easy way to remember this is theories are why something works, while laws are how something works. And as an example, we have the law of gravity, right? We know that particles are attracted to each other depending on their mass and distance away. And there's even a mathematical formula that relates the gravitational force between two objects. So with that being said, that's it for the scientific method. Once again, you should be filling out your graphic organizer or taking notes along at home. So let me know if you have any questions. You have my email. Have a great day.